All right, so what we are going to talk about today is why my ink pen is not selected. There we go. Polyatomic ions. Polyatomic ions. So what the fudge are polyatomic ions? Up until yesterday, you'd possibly not seen those in your work, but then all of a sudden some weird stuff started happening. You're used to ions that look something like this, like if I have calcium plus 2, or manganese plus 4, or chloride, Cl minus 1, or even oxide, O minus 2, right? All of these belong in a class that we call monatomic or monoatomic. Doesn't really matter which way you spell it. I've seen chemists spell it both ways. But monoatomic or monatomic ions are all ions with only one atom of one element. And this is where you kind of say, no duh. Well, the monoatomic means one atom, and that's literally what it is here. Now, remember, these are ions. When I say atom, that implies I have the same number of protons and electrons, but ions have different numbers of protons and electrons. They have a charge. So polyatomic ions look like this. I'm going to have to move my face out of the way. Whee! Fly up to the screen there. There's one. There's phosphate. There's ones like chlorate. These are all polyatomic ions. There's only one way to spell polyatomic. And you can probably guess poly means many, and so these are ions with atoms of many elements. So first of all, it's atoms, so we have more than one atom present. And second of all, it usually involves many elements present. There is at least one polyatomic ion that only involves, I can think of two off the top of my head, that only involve one element. But most of the time it has many elements present. Those are very rare polyatomics that have only one element present. But polyatomic ions, whenever we deal with these, we have, so for example, all of these are written like this. So for example, whenever I deal with that SO4, that -2 is the charge associated with this entire structure. So if I want to look at, for example, the gold 3 sulfate, notice the ending of this compound does not end in IDE. It ends in ATE. That means I have a polyatomic ion present. So to figure out what that is, of course, I could just Google it, or I can reference a list of polyatomic ions. I know this is not going to be a monatomic negative ion because of that ATE. Remember, monatomic negative ions, like this one that I wrote up here, have to end in IDE. This one does not. This is not sulfur with a negative charge. It's a very special polyatomic ion, SO4, with a -2 charge. To figure out what the formula of this thing is, I still do the same thing that I did before. I'm going to crisscross and drop the charges. So now we have an AU with the 2 and an SO4 that is in parentheses with the 3 on the outside. What this means is I have 2 gold ions, and I have 3 sulfate ions. Polyatomics are really weird. I don't expect you to be able to write the name of a polyatomic, the name of a compound with a polyatomic in it, or vice versa, right? What I just want you to know, to recognize, is that they do exist, and that 3 goes with the entire thing. We're going to do some math with these a little bit later.